So here's your powers chart. If you want to write it down, if you missed class, make sure you push pause and write it down. And then what we're going to be looking at now is what are called exponential equations. The variable is in the exponent, right? And they've got an example here. If 3 to the x equals 81 from your powers chart, you see that it's equal to 4, okay? But what we could do as a little, like, I'm pretty sure most of you would have just said, I see it from my powers chart, and I go from here to here, and just say the answer is 4. Because exactly like the question I gave you, I went 4 to the x equals 16, you saw that it was 2. But as an intermediate step, we say, could we write both sides with the same base? And 16 is 4 squared. And if my bases are the same, does it make sense? Then the exponents would have to be the same. If those two sides are equal, that has to be true. So the second question that I gave you that was a little bit harder was this. 8 to the x equals 4. The question is, from your powers chart, could you write 8 and 4 as a power with the same base? So we look at our powers chart, and we notice that 8 and 4 are both in the same base of 2. They're in the same column as 2. So what that means is that I could rewrite 8 as 2 cubed. And I could rewrite 4 as 2 squared. Now on the left-hand side, I have my power rules from grade 9. What did you do when you had a power to a power? If I had 3 squared to the 5. This was equal to 3 to the 10. We multiply. And so if I have 2 cubed to the x, I can multiply those and just get 2 to the 3x. And if you can get the bases the same, does it make sense that these two things would have to be the same? So you'll see me write, like, this is a mathematical observation. So I often write, so I'm just making an observation that therefore 3x has to equal 2. And you get x equals 2/3. Really cool, try that on my calculator. 8 to the exponent of 2/3. Sure enough, it's equal to 4. But not something that mental math you just saw and said, I knew this. So we're going to use this strategy of, if I'm trying to solve an exponential equation without my calculator, my goal is to write both sides with the same base. I can use my powers chart to look in columns to see which of these bases will work. And since 4 and 8 were in the same column, I could rewrite 8 as 2 cubed with a base of 2, and I could rewrite 4 as 2 squared with a base of 2. If my bases are the same on both sides after exponent laws, it must be that the exponents are the same if they're equal. So the 3x had to equal the 2. And I think you're going to enjoy this because this is like a little bit of mental math and a little bit of algebra. And sometimes numbers appear in more than one column, so you have to even have options. Like, do you see that 4 and 256 on your powers chart are in the 4's column and they're in the 2's column? So you could change 4 to 2 squared, or you could leave it as 4. I'm going to leave it as 4 because make things a little bit easier. 256 is 4 to what power? On your powers chart? You see that it's 4 to the 4? Now my goal is to write both sides with the same base. I'm close, but unfortunately this 4 is in the denominator. Do I have an exponent rule that would let me move it to my numerator? That's my negative exponent rule. So 1 over 4 to the 4 is 4 to the negative 4. So we're really going to use all of our exponent rules from grade 9 a lot in this unit. And now that our bases are the same, I'll put a green box around this and I'll go, so x would have to be minus 4. And that's my final answer. So I can get my bases to be the same on both sides. Then the exponents have to be equal, and then it becomes really easy. Part B. We've got 27 and 9. Are they in the same column of a base in your powers chart? Yes. They're in the columns of 3, so I can change the 27 to 3 cubed, and I can change the 9 into 3 squared. And notice that whenever I change them, I put them in brackets, because I might have exponent rules from grade 9 I have to deal with. In this case, I do, for sure. On the left-hand side, 3 cubed to the x, power to a power, we multiply, so this becomes 3 to the 3x. Same thing, power to a power, I multiply here, and when I multiply, I'm going to have to distribute. I'll get 4x minus 2. There's my exponents, the bases are the same, so it becomes obvious that the 3x has to equal 4x minus 2. You move the 2 to this side, the 3x to this side. We get that x has to equal 2. And you can double check this with your calculator. Let's try it. 27 squared would be 729, and 9 to the power of 4 minus 1 will be 3. Do these come out to the same number? They do. Very cool. Questions for practice for number 1. Three, 4, 5, and 6. So we've already practiced some exponent rules. Power to a power as an exponent rule. We practiced our negative exponent rule. Our next example is going to practice some more exponent rules that you may or may not have forgotten. Hopefully not, but we'll see.